You're making weird faces again.
No, I'm not.
You make weird faces, honey.
You have to read at the table.
Well, weird faces should go along with a weird data set. Let's talk about how would you handle if you had categorical and more categorical variables. What we have here is beeswax, paraffin, and soy. I've put them in alphabetical orders, so that's the same as R would do. Baseline would be beeswax. But we also have the type of wick. We have cotton and zinc, alphabetically cotton. So there's really 6 categories here, and we want each of these categories to be free to have its own slope. Let's pretend that these numbers here are the ones that we want. So if you're good, you can try to memorize this. But the question is, how would we tell the computer to look for the different slopes in such a way that it can give all 6 categories the right slope? Well, to begin with, let's just start with the baseline. The baseline slope, it was supposed to be 20, remember, right? So we're going to have 20. And if I don't tell the computer to be careful of the categories, then everybody gets 20 because we haven't separated by categories. That's great for this group, but it's not the right number for the other groups. So if we want to fix the values for paraffin, let's look right here. I need it to be 80. The baseline is 20. So I can tell the computer when we're talking about the paraffin group, let's add 60. When I'm talking about the soy group, let's add 40. That will change our value to be 80 here and 60 here, which is what these groups needed. That's great. They're now happy. But if we look at some of these other groups like this one here, beeswax, zinc, this group is supposed to have a slope of 100. And we've told the computer to be careful of the type of wax. So we've included wax in our model, but we haven't included the wick type in our model. So if we tell it how to change from a cotton to a zinc wick, what will happen? We will change all these values to do plus 80. Adding 80 to the 20 gives us a value of 100 right here. That's what it's supposed to be. So now this category has the right slope because we've included wick. And these categories have the right slope because we've included wax. But this one right here is not what it's supposed to be. It's supposed to be 40, right? So we're pretending that the data has a slope of 40 right here, and instead it's 160. Why is it 160? We started with a baseline. We added a wax effect, which increased it by 60. We added a wick effect, which increased it by 80. And then we're left with 160. It's not supposed to be 160, it's supposed to be 40. So what do we need next? What we need is something for this specific wax and wick combination. We need to subtract 120 to put it where it's supposed to be. And for this exact wick wax combination, subtract 20 to put it where it would be. Now, all our slopes are going to be correct. What's coming up is when I do the analysis for this, I'm going to include wax, and I'm going to include wick, and I'm also going to include wax times wick, which will allow these categories here to be specifically what they need to be to have the right value. A lot of students get confused about why do you need to multiply them if just putting in wax and wick do give you 6 separate slopes, but not all the categories are at the right value. Also, sometimes students get concerned when they see a slope of negative 120. What does that mean? It just means that we are changing the baseline and wax and wick effect to be where it should be. So that's why when we do all these, we're going to take 2 pieces, and instead of keeping them separate, we're going to multiply them together. Here's the candle's data set, how much heat the candle gives off, how long the candle burned for, and we have different types of wax and different types of wick. I've read in the data set. I want to look at the plots, make sure that there aren't any obvious errors or outliers. Not so much, okay? So now I want to make a model. I'm predicting heat, and I want time in there, and I want wax, and I want wick. Now I also want for time to be affected by wax so that the different waxes have a different time slope. And I want time to have a different wick slope. And then here I'm going to put time and wax and wick. Why do I need this guy in there? This is what's going to allow the different slopes specifically for those inside groups like I was showing you on the board earlier. This is going to say I want every possible way that these variables could be affecting each other. How do my residuals look? They look really nice. And my summary fit has a lot of pieces in there because I have 6 categories and I need 6 different y-intercepts and I need 6 different slopes and I need for them to be able to be different. And here is that little piece that I was showing you on the board that changes the paraffin zinc category to have its own unique slope. And by looking at the p-value here, I can see I definitely did need for that term to be in the model in order to get the best predictions possible. In the next video, let's make some hats so that we can draw our picture and then do a report.